All right, 9.3 deals with composite figures, or the area of composite figures. So you're going to learn to use the area addition postulate to find the area of these composite figures. So we're going to kind of define what a composite figure is. So a composite figure is made up of simple shapes such as triangles, rectangles, trapezoids, and circles. Basic shapes, things that you've done with and know how to find, or should know how to find the area of. Right? And so what we're going to do is to find the area of these composite figures. We want to find the areas of these simpler, basic kind of geometric shapes, and then we want to add them up together, which is the area addition postulate. All right, so let's kind of go ahead and jump right into this and give you an example of what I'm talking about. So see this figure that's kind of, it doesn't really fit a typical polygon, things that we would think of when I would say, show me, or what is a pentagon. Because this has 5 sides, and it is a pentagon, but it's not what you think of or what I would think of when we look, or if I were to ask you to draw a pentagon. But we can find the area of this by simply taking this shape and splitting it up into 2 simpler geometric shapes. All right, so if I kind of extend this line straight down at a 90-degree angle, I create 2 shapes. First one being a rectangle, the other one being a triangle. All right, so I can find the area of this triangle and the area of this rectangle. So the area of the rectangle part is going to be equal to 22.5 times 37.5. Okay, which comes out to be 843.75 meters squared. Now, if I want to look at the area of this triangle, first I need to figure out what this distance is, and I need to know what this distance is. All right, well, the easy one to find out right quick is to figure out what this distance right here is, and that is 75 minus 37.5, which is 37.5. Easy enough. Okay, now I can use a little bit of Pythagorean theorem to figure out what this right here is going to be. So I'm going to set a squared plus 37.5 squared equal to 625 squared. I'm doing some algebra here. I figure out that this A is 50. So I know that this right here is 50. Now I can find the area of this thing. It's going to be area is equal to 1/2 of my base, which is going to be 37.5, times my height, which is 50. And that comes out to be 937.5 meters squared. Okay. Then to find the area of this shaded part, I'm going to add these two together. So 843.75 plus 937.5. Which comes out to be 1781.25 meters squared. All right. So I had to do a little bit of extra work, but I was able to figure out what this triangle was, the area of this triangle, and I figured out what the area of this rectangle was, and then I simply added them together. All right, let's look at another one. This one, find the area, the shaded area, round to the nearest tenth if necessary. All right, so I kind of want to outline this right here, and I have this polygon, or this parallelogram, excuse me, and then I have a triangle down here at the bottom. And remember that the area of a parallelogram is base times height. My base is going to be 8, My height happens to be 5, so that gives me 40 feet squared. All right, area of a triangle is going to be 1/2 base times height. This one's a little easier because they did give me the base, which is 10, and then my height is 5. So that is going to give me 25 feet squared. All right, the shaded area means that I would have to do 40 plus 25, which gives me 65 feet squared. All right, next example, we have this kind of shape. This would be a half circle, and then this bottom part would make a trapezoid. All right, now area of a circle is pi r squared. But since this circle's cut in half, then I want to take half of pi r squared. So 1/2 of my radius, which if this whole thing is 20, my radius is going to be 10. So I want to square that, and I'm going to just move the pi towards the end. So that gives me half of 100. That's going to give me 50 pi. But it does say to round if necessary. I'm going to save that to the end before when I add these two together. The trapezoid is going to be 1/2 my base 1, base 2, which is 20 and 32. And then times my height of 14. Putting that into the calculator. I get 364. All right, so I'm going to put this in the calculator. I'm going to type in 50. And then the pi button, if you're not familiar with the calculator, it's going to be right here, this little up arrow. So I'd hit second. I want to do 50 pi plus 364. And so my area is going to be equal, it says round to the nearest tenth, so if I approximate that, that's going to be 521.1 millimeters squared. Okay. Next, we have a different shape. This time, this is taken out of this triangle. So I need to find the area of the triangle, which is going to be 1/2 base times height. So 1/2 18 times 26, which comes out to be 234 feet squared. All right, again, I want area is equal to 1/2 pi r squared. So this time, if I take half of 9, that gives me 4.5. And so let's see, if I do 4.5 squared, that comes out to be 10.125 pi. So I want to take my area, and this time, since this is kind of cuts into the triangle, I want to subtract the area of the half circle. So I'm going to do 234 minus 10.125 pi. All right, so my area is going to be approximately 202.2 feet squared. All right, next example for you to do, find the shaded area. So again, I'm going to have to subtract this kind of white space, which happens to be a trapezoid. The area is going to be half of my diameter, which is my radius, so this is going to be 10. So this would be pi r squared would be 10 squared pi. So that's going to be 100 pi. Area of the trapezoid is going to be 1/2 of 12 plus 20 times 8. That comes out to be 128. So again, I'm going to have to take the 100 pi for the whole circle, and I want to take out the trapezoid. All right, and then so rounding to the nearest tenth, that's going to be 186.2 centimeters squared. All right, now this last little bit is going to be doing some estimations with these irregular shapes. They're not polygons, but we can still find the area of them, and we can estimate the area. So what I kind of do is I look at this shaded area, and I count these ones that are completely shaded in. So this would be 1, 2, 3, 4. All right, and then these right here, I'm going to kind of count them as halves. So that would be half, and then this would be about half, estimating it. So I would count this together as another one, so this would be 5. And then same thing here. Actually, this would be a half here. And this one I would go ahead and approximate that to be a half. This one it's almost half, so I'd go ahead and count that as a whole one. That would be 6. These two together would make 7. And then I would have this one right here that would make this 8. If I counted this together, that would be 8 to make that halves, 2 halves right there, and then I have this half right here. So I would say this would be 8.5 centimeters squared if I estimated that. All right. Same thing with number 7. We want to kind of try to estimate these. I have one full one here, a full one here, and here. All right. This right here, I would count that as about half, or actually about 1. It looks like this piece could fit right here, so that would count as another one. I would count that as 4. This piece and this piece, I would count that together. That would make 5. And then I would combine these together to make 6. So that would count that as 6 feet squared. It's an approximation. You're just estimating it to see what you could count off of this grid.